Good morning, guys of grade 9. Today, inshallah, we're gonna pass to lesson 2 of chapter 18. We're still talking about studying the space. So, in that section, we're gonna talk about the most important tool that enables science to study space more in details or help them to know more and more about the space, which is telescope. So, if we just need to recall from the first lesson that the first scientist who made a telescope and that was kind of leverage or advantage for him make him able to record a lot of observations about the universe and space was Galileo Galilei. So today we're going to learn about different types of telescopes, what the importance of telescopes, how they work, and so on. So by the end of this lesson, we should be able to compare the refracting telescope with the reflecting telescope, explain how the atmosphere limits the astronomical observation, and explain how astronomers overcome these limitations or how they overcome this problem, and finally list the types of electromagnetic radiations that astronomers use to study the objects in space. So first of all, we start by telescope. So once we ask you what is a telescope, simply you're gonna say telescope. It's just a device or a tool, okay, that is used to study the space. So simply here, that is the definition of a telescope. It's an instrument or a tool that gathers the electromagnetic radiations, which mainly is light, okay, and that's here. So we are gonna observe or see, okay, what happens in the space. So that means telescope is a device that is going to collect the light which is already emitted from or reflected from different celestial body like stars or even planets or moons or so on. And once we see, okay, this image, we're going to observe what happened, how they look like, and so on. So there are many different types of telescopes. First, always start by optical telescope. And once we say optical, the word optical, it means that something is related to light or based on light. So that means this kind of telescope, they mainly work on the receiving the light as electromagnetic wave. Okay. So let's find here. First type is the refracting telescope. So the word refract, it means it depends on the refracting of light. So first of all, we need to remember what meaning by refract or light refraction. It is the change of the light direction, which it passes from a medium to another medium. Or once the light passes, okay, or change its speed, it will change its direction. We call this the refraction of light. So the refracting telescope actually based on the idea that they use lenses, okay, lenses just pieces of glass, okay, that has a certain thickness that make light refract and changing direction to be focused or to focus the light rays into a certain point in which we need or we need to observe, okay. While here we find the reflecting telescope, it depends on the reflecting of light or light reflection. Light reflection means the bouncing or turning back of light once it hit a reflecting surface, like when it hit a mirror. So that means the reflecting telescope uses mirror instead of lenses. So to clarify the idea, let's look here at this picture to represent. That is the refracting telescope, and that of course the simplest refracting telescope because it just contains two lenses only. Of course, we have a complicated refracting telescope that has many lenses, but we just explain the idea on the simplest one. As you could observe here, just so we have a tube. In the beginning of the tube, we have this lens, okay? We call this lens the objective lens. Why it's objective lens? Because the lens which is toward the object which we observe. So as light rays come already straight because they come far away and light rays are moving straight, okay, in constant speed. So they will pass through the lens. So this is a concave lens, okay. So we call this sorry, this is a convex lens. Convex lens, that means the lens which converge the light or make the light focused or collected in one point. So as light will pass by this convex lens, it will be collected or gathered in one point, we call the focal point, okay. After the focal point, the light will start to diverge again, okay? And once it diverge again, here it comes the rule of the second lens, which is the eyepiece. This eyepiece will allow the light rays to become parallel and focus to your eye, which is you're going to look at from this side, so you could observe what's happening in the space. Of course, the picture which you're going to receive is considered to be smaller picture regarding to the object which we observe, okay? So the idea of the telescope that is gonna prefer, it's gonna form an image for far distant object, not large image. Actually, it's smaller object because of course the celestial bodies, planets or moons or stars, they are too big, okay, or too huge. So the image which we receive is smaller, but it make a closer image. That means make the objects to appear closer to observe them. So here how the refracting telescope works. It depends or uses lenses, okay, and depend on refracting light. Here is the reflecting telescope. The question is why we need reflecting telescope if already the refracting telescope is okay, or does it work? Actually, refracting telescope is okay and it used a lot, okay, for many years, okay, and then the telescope which is made by Galileo Galilei, not this one, of course, simpler than this or little, okay, um, not in that quality, okay, because it's improved within time, but there is a problem, okay, with the refracting telescope. What the problem that as the size of refracting telescope increases, or if we need to record farther and farther objects, it means that we should use larger lens. So once the lens become too big, it will be too heavy because it's made of glass. So it will be too heavy, and that will also the thickness of this lens will increase, which cause the light to be diffracted, or that will cause light to be scattered in some way, and in that case the image will not be clear or will be blurry, or image will not be forming. So that means we have a certain size or a certain limit that the lens can be used. Bigger lenses actually will cause damage of the image, or will not form a clear image, so we cannot use the refracting telescope for this further object. That's what pushes scientists to find a way to solve this problem and to make a pair telescope that could overcome this idea. So scientists, instead of depending on refracting light, they start to use the idea of reflection, because in reflecting we use mirrors, and mirrors don't have the same thickness like the lens, so somehow mirrors could be supported. That means I could put a kind of metal piece or whatever, any solid object behind the mirror that's supported, and could make it, okay, somehow fix it to reflect light, while the lens cannot be supported, because as you can see the light passes from the two sides. So in the reflecting telescope, the idea that we have a concave mirror, okay, this concave mirror is gonna converge the light or collect the light rays also. So simply here that here we just have an opening, no lenses here. So we find that the light will pass, okay, through this tube, and at the end of the tube we find this concave mirror. The concave mirror will reflect the light, okay, but the light will be convergent or just be focused. Then here we have another mirror, okay, that is gonna reflect the light one more time to the eye lens, which you are gonna observe through it, okay. So like this, okay, we depend on reflecting light instead of refracting light. That's why we call the reflecting telescope. So reflecting telescope, or the complex reflecting telescope, it contains many mirrors, and it could gather light or could collect light from very far distant object, and it enables us to observe a lot of celestial bodies, okay, that are very, very far in the space, okay. So here like this, we could find that the reflecting telescope somehow solved the problem of that refracting telescope. So that's the difference between the reflecting telescope and refracting telescope and how they work. Then we find here, okay, that a very large reflecting telescope, as we said, it may contain many or several mirrors that work together to collect light and focus them on the same area. So you somehow you could receive a multidimensional view, okay, of the object in the space. Here we said we also, whatever we're using the refracting telescope or the reflecting telescope, we have problem that as light passes through the atmosphere, already the electromagnetic waves of the light is affected by the atmosphere particles, which means due to the different gases that found in the atmosphere, or even whatever the particles that are suspended in the atmosphere, it may cause, okay, the light not to be received easily. The light may be diffracted or plugged or reflected, or somehow some of the light will not, okay, pass easily to the telescopes. So scientists try always to put their telescopes on over mountains or high elevations to be sure that they somehow near to the clear sky, and to avoid the most obstacles that found in the atmosphere. But still also not all the rays could, or not all the light rays could easily passes to the telescopes. That's what pushed the science to figure or to think in another science that if we could make a telescope in a space, that means we already put the telescope in the space to avoid the particles of the atmosphere completely. In that case, this telescope will be able to collect all the radiations from the atmosphere and then send the data by whatever the method, okay, as electromagnetic wave that could be received stations found on the Earth. So here, like this, guys, that's how scientists think about telescope, or how they start to improve the telescopes over time trying to reach further distance, okay, in the space and studying more objects. So we are gonna stop at this point, guys. Study this part very well from your textbook, and if you have question, I'm waiting for your question. Thank you and goodbye.